Hello everyone, my name is Thakker. I'm a knowledge engineering research fellow at the University of Leeds. I'm going to present our work on Taming digital traces for informal learning, a semantic-driven approach. Specifically, I'm going to talk about the motivation behind this work and the problem we are trying to address and how we are addressing it. The work was done with, in the context of Unreal project. Obviously, it's very obvious there, but I have my colleagues as well taking part in this work, Democles, Vanya, Lydia, and Paul. After introducing myself and the team, I would like to introduce you to Tom. Here is Tom. Tom is 20-something. He's finishing his degree. He's applying for jobs, and luckily he's got a job call. He needs to go for an interview. Doing his first interview, he's nervous. He's not sure about a few things in the interview process, what sort of body language I should have, and so on. So what he can do is he can go and talk to people who have experiences, friends, colleagues, and mentors, or he can. He being a 21st century learner, he could go to something like YouTube. He can enter a query, he is not sure of handshake, he types job interview, handshake, and he gets some videos, he can watch one of them. Or even better, he looks at this comment, which was on one of the videos. It's from the perspective of an interviewer. Interviewer here is saying that, yeah, in job interview you do handshake. That's my opinion. Or he can read, the blog. Somebody has kindly written a blog about their job interview experience, and he can find that useful. He's on Twitter, and he might have subscribed to job interview related tags, or he can search for them, and he might come across helpful tweets like this. Somebody's talking about, dressing sense as well in the interview. And the other tweets that you can see, they could be equally helpful. So you can see where I'm going with this. The motivation of our work is exploitation of digital traces as a source for informal learning. This is our motivation, and obviously the Tom here is fictional, but the scenario I've with about Tom is quite plausible. This sort of informal exploration will happen in real situations where people go and do such type of informal exploration, and informal learning can happen involving digital traces in variety of situations, not only job interview. What is equally plausible is that you would be able to find such sort of digital traces. For example, all the tweets, the video comments are presented where they were not, prepared for this presentation. So it's equally plausible to find such sort of digital traces on social web. Because people go and write about reviews about the services they received. They will write comments on YouTube videos highlighting their situation, offering their opinion, as the interviewer was offering his opinion. So, in the sense, we are saying that such sort of digital traces are possible to find. The problem is obviously finding them, the right ones, aggregating them, and organizing them somehow. And we're calling that sort of a big list, and you need to tame it properly. So we're terming it taming digital traces. That's why the title of the paper is there. What is also important is that this sort of exploration and informal learning is happening on an ad hoc basis outside in social media environment, and it would be nice to provide some sort of exploration environment where this sort of informal learning can happen. And as you show in one of the first animation, where he entered the job interview handshake. So he knew about handshake. What if somebody doesn't know what would be involved in terms of body language in the job interview situation? then obviously they can benefit with some sort of scaffolding where they are told about relevant things about an activity. And that's where we're looking at utilizing, also for this organization of digital traces, but also for the exploration of environment. We're looking at utilizing semantic technologies, mainly something called semantic data browser. I'll come to that in the next slide, but also the concept of semantic images, which I'll be covering in my presentation. That's an example of semantic data browser. This is the one we have developed. It's a simple scenario I'm demonstrating here. In a semantic data browser, what you generally have is you generally have a focus concept. So what the user or learner is looking at the moment. So in this case, it's body language. You have some facts about that focus concept. So here in this case, it's facts about body language. So it's a tool. It's a type of nonverbal communication. And for example, eye contact is a body language. And you can have content which is tagged with this focus concept, or things which are related to this focus concept, things which are related to, for example, body language. So here, the one you see with the book is actually a story about a nervous applicant, and there is text there, and there's a reason why it's appearing as part of the content for body language. Similarly, the two pictures you see are comments, which are on YouTube video, and they are displayed here. So user could read it, and he can, and all the blue things you see there are clickable things. So he can look at a fact, looking at eye contact is a body language, and then he can click it and go to the next page. So that focus concept will become eye contact, and then various things around it, like I show you in body language. So how to build a system like this? We have a processing pipeline for building a semantic data browser. It's applied in this context, but we apply it into other contexts as well. And it's a fairly generic for building a semantic data browser for an activity. The first one is you need a way to collect the digital traces. I'll talk about that in my next slide. You need ontology and underpinning as well, and there is something called Linked Data Cloud, probably you know about it, and that could be also code there, or you might have to do something bespoke. And then you need a tagging mechanism. You call it semantic augmentation, which basically tags content with ontology, and you can also you need to have some sort of querying mechanism of querying ontology and querying semantically augmented data. And then obviously you need some sort of interface if you are handling to learners, so some sort of browsing and instruction mechanism. Starting with first, I'm going to go very briefly with them because they are described in the paper in detail. Digital traces collection is interesting because it's a blessing that you have social web APIs. You can provide nice pipeline. You can plug in and get a variety of digital traces such as blogs, tweets, and YouTube videos and comments and so on. Obviously, the immediate problem there is noise, and I think the data mining could be an interesting way to handle that problem. We have done some sort of experiments on that, where we build a sort of a classifier to rule out the noise and select the relevant comments from YouTube, for example, and it's reported in the paper which is set in 2012. You can also envisage role of tutors or trainers in setting those standards. So we can say that okay, these are the things which would be useful and for the learners to read and play. So you can imagine their role in there. Kind of there is if you look at this document, Radiford et al. There is a policy brief by GRC which says that with social media there will be impact of learning in Europe, and the roles of users would be changing. Next big bit is related to semantics. Our was talking about ontology underpinning. If you're lucky, you will find the domain ontology you need for linking the cloud. We are not that lucky. This domain we are experimenting with in Hungary is personal communication, and there are very few things about interpersonal communication in data cloud. So we had to build something custom, but obviously using what was building on what was already out there. One of the main principle of linked data cloud. So we have built ontology on geography activity, and we have other activities, interpersonal communication activities in the project, such as manual interviews, mentoring, all of them then we classify into interpersonal communication. So rather than building bespoke ontology for those use cases, we have looked for something which can give us some sort of upper layer. Guide us what should be the interpersonal communication activities. So what should be common things between them, and we ended up using something called activity theory, which is from 1950s. Psychologists work on studying human activities, and one of the things which are common across various human activities. And we are not talking about here activities in terms of what the users do in the system, interaction and so on. We're talking about human activities such as mentoring and so on. So this is an interesting ontology for this, which we have made available in this URL, and the verse is also reported as a reference is there. And semantic augmentation service. This is basically a tagging service which links content with concepts from knowledge base, ontological knowledge base, and there are few components for that. That are not. I think I'll skip that. But I'll say, for example, that comment there about handshake. If you give that to this service, then obviously there is a mention, a surface form handshake over there. So it obviously attaches handshake concept from the ontology to this comment, but it also indirectly can infer that using the ontological relationship that this comment is somehow related to body language or handshake body language from the ontology. And it's a RESTful service which is available. The other service is a semantic query service. Again, you have ontology, you have semantically augmented data, which is done by the previous service I described. Then you need some sort of mechanism to access it, and this is the service which provides that mechanism. Again, the details are in the paper, and I'll be happy to talk about. So this service basically gives matching related content. It's also possible to use this service to build a tag cloud of the content. What are the key concepts in the content? Again, available as a REST service, and this is what is used in this pipeline and in this semantic data browser. Now, I'll come to the interesting bit, very interesting bit. If you look at the pipeline I described before, that can give you a semantic data browser. And this is how we have done things differently. One is underneath it, but lots of you see other state of the art semantic data browsers. They more or less implement this sort of pipeline. The problem there is building the data browser like this and using it for learning is that learning is in charge there. These browsers. And then the cognitive onus is on learning. Somebody you might not know what is the conceptual space here. And you are allowing him to browse there, which is fine. You want to preserve the exploratory nature of browsing, but it might be bit of fun. So we were looking for building some sort of framework to inject some sort of proper learning into this, and we were looking for some sort of intelligent techniques. And as I said, and I'll repeat again. That we wanted to, preserving the exploratory nature of this tool, as well as, how they would do it in the social environment is very important. So we have turned to a concept of nudges. The architecture there is called choice architecture. It allows, it's all about preserving somebody's freedom, but also influencing options in a way that will support users to act in their own interests. That is what this architecture is about. It has guidelines, it has components which are applied in various other contexts such as policy administration and so on. And nudges in learning, like you can see below was smiling, has been looked at from the perspective of learning before in this very conference. They have looked at it from theoretical aspect, how it could be applied in learning context. So our contribution is to how to implement something like nudges and then the guidelines and components there, and some of the recommendations provided by Milos and Ralph into a tool like this. So that is where our contribution is. We call it semantic nudges, and we have shown how this nudges could be implemented into semantic browsers. The details are in the paper, but mainly components we can map already into the data browser are two. First of all, the nudges architecture talks about default options, and it says that they are very powerful because that's what most of the people will end up with, and learners would be. So it should be carefully designed. So the data browsers, the screenshot I've shown you before, have some facts around the focus concept and what they look and what they explore is very much dependent upon what you display there. And it will affect and it will influence the path the learners will be taking. So we have technically shown that entity summarization is the technique which could be applied there. The second one is about prompts. Again, the architecture. If you look at the second line, it says that if you want to influence choice, this could be realized by suitable alerts, and it could be we have translated that to prompts. Generating prompts in this data browser. So this is a snapshot of if you improve it with the signposting, how the semantic data browser could look like. So rather than displaying all the facts about a key concept or a focus concept, we have key facts. So we have looked at, for example, nervous. These are the things a learner could be looking at, rather than everything. There is all facts still there. It's just you can expand and look at, but they are hidden there. These are the things if we look at the path which should be followed, which should be explored. If these are the facts which are clear. So that is what we mean by signposting and key facts. Similarly, we have a prompt mechanism. Some of the examples of prompts are given in the paper, and I'll quickly move to exploratory study. The exploratory study was, twofold. The aim of exploratory study, we wanted to see, basically, we wanted to see the feedback on, potential benefit of using digital traces, semantically augmented digital traces, and we also wanted to get feedback on semantic nudges, and how it could be helpful for informal learning. So we carried out the exploratory study. The domain was job interview. The digital traces we used were from comments from the YouTube. These were filtered with the noise suppression mechanism I've explained before, and some of the comments were collected within the iPhone. So we gave users or some participants, this is outside the exploratory study, somewhere before, some of the provocative videos, and people commented. And that's what we used as part of this exploratory study. Also, the Agile team kindly provided some blog-like stories on job interviews, and that was used in this experiment. So we had digital traces as part of this exploratory study. In terms of participants, 5 interviewers and 5 interviewees. There is statistics on that, and then we had experienced interviewers as part of this study. So we get this tool, when it came to study, each were given some familiarization, some sort of familiarization time period, 5 minutes, and then they were asked to perform these 3 tasks. The task number 1, so they were kind of questions that they were supposed to do the exploration and find out answers for them. So what nonverbal cues can you observe in different situations, and so on. So these were the questions which were asked, which were basically tasks for them. But the answers is not we were after, whatever answer they gave. If it was we were after the feedback, various bits of the nudges they were using in the exploration and feedback on that. So this is the responses we got. We did qualitative analysis of the response. They had a check, they had a form to fill up with us, and then we also captured a video of it and later on analyzed, and this is the qualitative analysis of it. So they said, this is one of the experienced interviewer. They said that examples are the beauty of the system. I'll learn from examples. The other one said that this is again participant number 10, one of the more experienced interviewer. Anything that facilitates the preparation of training material and provides real-world examples, so that training is very helpful. It also worked as a stimuli. They reported to us that it made me reflect. It made me to think. Previously, I was doing things. I'm an experienced interviewer, but I was doing things intuitively. They wanted to provide their viewpoint due to their culture, because one of the comment was saying that shy is a negative thing, but a person from Chinese origin said that no, it's not always the case. In my culture, being a shy in interview is not a bad thing. And they were able to sense the diversity on the selected topic. So basically, this is how it was. So when they are exploring, they have a video, and there are comments which are gathered around it. So they were kind of doing their implicit sense making of it, and they were kind of looking at whether there was a diversity or everybody was saying the same thing. The green red lights elements where we need to be careful. Some of the warnings we got from this analysis is that things could be taken out of context. So when somebody is reading a comment, if he's a learner, he might take that as a norm in every situation. So something needs to be done about that. If you looked at the feedback on semantic nudges, overall they were reported. There was a positive response for that. It was a fruitful way. They say this is a fruitful way to provide for. Is there one me? I think I should be done in 1 minute.